assessment on Thursday. And so I am recording this and I'm going to go through the review. All right. So it behooves you to follow along. Okay. And let me just, I'm going to go draw and I want to freeze this. Good. And pull that down. Okay. So the first problem that we're going to look at is this one here. Go ahead and tell me whether or not you guys can hear me. Everybody can hear me? Yes, no?
Yeah.
All right, good. So I'm going to do a lot of speaking today, which I don't usually like to do. I'd rather you guys be involved. But in order for you guys to understand the higher level that these problems are going to be, I need to do that. So the first problem is quadrilateral ABCD. All right, ABCD is drawn on the coordinate grid. All right, so we got a coordinate grid, we've got quadrilateral ABCD, and which transformation will map the quadrilateral ABCD onto itself? So when they say map the quadrilateral onto itself, the vertices, okay, where our line segments meet, have to fall within on the other vertices. Okay, and it looks like I might have just had a chat come in here. Let's see. I have no power in my house and Wi-Fi is down because of the power loss. Okay, so Connor, you can probably simply follow along on your phone, and I will post this video for you guys to review. Let me pull this aside here and see if I have received any other chats. I'm here. I just can't get in. I'll do the warm up. Okay, Jernigan. All right. Isn't popping up. Asuncion. So let me just invite in Asuncion. Request to join, and request to join. All right. So when we're mapping onto itself, all right, when we're mapping something onto itself, these points have to fall on the other points. So what I'm going to start with is the coordinates of A, all right? And the coordinates there are -2, 1. So that is my XY coordinate, all right? So A is -2, 1. Now what they say is we're going to translate this to x -y. So essentially what I'm doing is I'm multiplying my XY coordinates by -1. So if I multiply -2 times -1, I'm going to get 2, all right? And if I multiply 1 times -1, I'm going to get -1. So when I take that point, so I've got A here, right? I've got A here, and that point maps to 2, -1. So I go over 2, all right, and down 1. So that point actually maps. So that's a possibility, all right? That is a possibility because it falls on the other vertice. Now let's do the same thing for the second option. Again, I've got I've got -2, -2, 1, all right? And we are going to map that one to where x stays the same. See, x here and x here, they stay the same. So I've got -2, and y is going to, positive y is going to convert to -y. So instead of us using 1, it's going to be -1. All right. So now if I map that point, I go over 2 and down 1. All right. That one, okay, that does not fall on one of the vertices, so that will not be an answer. So I can cross that one out. All right. So I'll cross that one out. Boom, boom, boom. Okay. Now let's continue on here. My next option is I've got xy going to yx. Now, we know that when x goes to y and y goes to x, we're usually going over the line of reflection, which is y equals x, okay? But let's go ahead and do this translation. So I've got -2, 1, all right? And in that case, we're going for the y value is going to go into the x area, all right? So that's going to be 1, -2, all right? So x became y and y became x. And now if I map that, I've got 1, -2. So I go 1 and then down -2, and that is not on a vertice. So that one does not count. Knock that one out. The last one here, okay, is going to be xy is going to go to -y, x. And Asuncion just said she's in, so that's good. All right. So what I'm doing here, again, I've got my original point A, which is -2, 1, all right? And x is going to become -y, and y is going to become x. So -y, which would be +1, now becomes -1, and x stays the same, but we're moving it to the y coordinate, so it's going to be -1, -2. So I go -1 down 2, and that is in the center of the trapezoid, or in the center of the quadrilateral, all right? And that doesn't map to one of the vertices. So that one doesn't count. So our answer here is the first one, which is the conversion of xy to -x, -y. And the same thing would be true like if I did point B, just to test this. All right, so point B is 2, 4, 2, 4, right? And I'll just do this down here, 2, 4. And that's going to, just testing this here.
Mr. Ferreira,
Yes.
1246, is that Miss Bennett over here?
I'm not sure, but you can check the, yeah, I would
Okay,
just,
she's coming from freshman building to go to a different class
yeah.
that said on the door, and it said 1246.
So if there's a sign out,
Yeah, it says 1246 is in here.
okay, yeah, so just check the doors. Sorry about that, guys. So we've got 2, 4, and now we're converting that to -x, -y, so it's -2, -4, all right? And if I go -2 and down 4, I come up with B mapping to the vertice of D. So the answer here is going to be the first one. That's mapping onto itself. Mapping onto itself. All right, so that's the first one. Any questions there? Go ahead and speak up if you have any questions. No?
Sorry.
Yes. Go ahead.
I didn't understand your thing.
Okay, so what I did there, Randall, all right, was I started with point A, and in order for a quadrilateral to map onto itself, the vertices have to map onto themselves. So all this work that I did here, okay, that was just on point A, and I went through each different scenario that they gave us. All right, so I'll erase some of this stuff for you. It's a little messy. All right.
Oh, God.
So what we have to do is we've got to understand those translations. So the first one, using point A, right? It's -2, 1, right? So -2, 1, and we need to convert that. We need to translate it or transform it into negative x, negative y. So essentially what we are doing here, let me do this. I'm just going to do the first point, and I'll do it a little more illustrated, okay? So we're going from x comma y to negative x comma negative y. So in order to get, if I told you that x was 2, right? And I needed to get the negative, right? I would just multiply that times -1, and that would give me -2, right? So in this case, we've got -2 times a -1. That's for my x coordinate. And then I've got 1 times -1, right? And then that translates, -2 times -1 would be 2, right? And 1 times -1 would be -1. So if you look at that, right? 2 comma -1, I go here, I go over 2 and then down 1. And that point right there, that would be your A prime, right? So that maps from this vertice to this vertice. And then I did the same thing down here for B, right? So let's look at B, right? So point B, the coordinates were 2 comma 4. So if I was going to convert that to negative x, negative y, so if I'm going from x comma y, right, to negative x comma negative y, right? Well, what I have to do there is I've got to multiply by -1, right? So I'll expand this math for you. All right. And so now I've got 2 comma 4, and I've got 2 times -1 comma, and then 4 times -1. And that is going to give me the answer. 2 times -1 is -2, and 4 times -1 is -4. All right. And now I map that point right there, and I've got -2, 4. That's where we ended up with point B. All right. So I've got -2. I go over 2 to the left, and I go down 4. All right. And point B maps to D. So that is B prime. Now I could go through C and D, or C and D and show you that they're just reversing spots. But I'm telling you that this is the correct answer right here.
So you gotta stay on the shape, on the line of the shape.
Yeah, yeah. And again, the points have to map to the vertice A needs to map to another vertice. The vertice B, okay, which is point B, needs to map to the other vertice. All right. And again, you can do all those, but what I'm saying is just your strategy here in the test is to just grab one of your points and make sure that it maps to another point on that is within the quadrilateral. All right. So let's move on from that one because we have another one which is going to be similar. You okay with that, Randall?
Yeah.
All right. So let's go down to the second one. All right. So with this second one, what they tell us is we've got line segment RS has endpoints R, which is -2 comma 4, and S, which is -4 comma 1, -1. All right. So the first thing I want to do here is I want to map these two lines. So I've got RS, which has endpoints -2 comma 4. So I go left 2 and up 4. 1, 2, 3, 4. Okay. And that is going to be my R point, which is -2 comma 4. All right. So that's my first point. And then my second point here is S, which is -4, 1. So I go left on my x-axis, 1, 2, 3, 4, and then I'm -1. So that is my second point, and that is going to be S, which is going to be -4, -1. All right, and I'll connect these lines, or I'll connect these points. All right, and that's my first segment. That is segment RS, okay? Then they tell us line segment R, and notice that it's double prime. It's not, so we're making here. All right, so we're doing a reflection, a translation, or a rotation, and then we're doing another one, and you'll see that in the answers, okay? So R prime would be a single move, okay? That would be single. R prime prime, or double prime, all right, is a two move. We're making two moves. So what they tell us here is line segment R double prime and S double prime has end points, which is R double prime, which is 3, -3. So let's go 1, 2, 3, and 1, 2, 1, 2, 3, okay? And that is going to be R double prime. And that one is 3, -3. All right. So I just got that from there. Now we've got S double prime, which is 5, 2. So I go 1, 2, 3, 4, 5, and up 2, okay? And that is going to be S double prime, which we know is 5, 2. Now I'll connect these lines, or these points, all right? So if we look at this, right, let me ask you this. If this was a reflection and and we were just talking about a human being, and R was somebody's head, all right, and they were reflecting in a mirror, let's say the mirror is right here, okay, would their head be or the bottom? What would you say?
I would say on top.
It would be on top. But in this case, R double prime is on the bottom. So we know that this cannot be a reflection. All right. It cannot be a reflection. So I'll eliminate that. So anything that says a reflection that we're going, so here, one of our options, so we've got this option, we've got this option, we've got this option, we got this option. It cannot be a reflection. I'll cross that one out. So that one is out. Now, let me ask you this. If we just did a translation, which essentially all we're doing is we're moving points in the same order, or the same orientation. So if we did a translation of these points, R would go to R double prime, right? But in this case, it goes to S. Well, that doesn't work either. So it can't be a translation. So I'm going to take that out also. So let me, let's see, I got a chat coming in here. Bear with me one second. Yeah, no problem. I'll make sure I mark you here. I'll do that. I'll do that real quick here. Let me just go in, and Yanyo Valido is now here. Attendance by name, and Yanyo Valido. Good. All right. Okay. So we've eliminated the reflection and we've eliminated the translation. So that leaves us two options. It leaves us the option of a rotation of 180 degrees or a rotation of 90. So let me clean this up just a little bit. We now know that the translation doesn't work and the reflection doesn't work. So now we're talking about a rotation of 90 degrees counterclockwise. So the way that I like to rotate points all right, is I want to create triangles based on my X or Y axes. So I'm going to change colors here, and I'm going to create a triangle that goes to my R point. So here, my triangle off of the origin, okay, off of the Y and X axis, my triangle to that point is going to look like that. Now, if I was to rotate this triangle right here, 90 degrees, right, what would happen is I'm going up 1, 2, 3, 4. I rotate 90 degrees, all right? So I'm just rotating one quadrant, and I'd go left 1, 2, 3, 4, and then I'd go down 2. All right, so I'd go down 2. So R prime would be down here. All right, and that would be my new triangle. But we know that that doesn't map. That's not far enough because R prime would end up here. I'll put that in red. R prime would have ended up here, and S prime, okay, would have ended up somewhere down here. So 90 degrees doesn't work. I can cross that one out. And if you look, we're talking about going into two different quadrants. So it's a rotation of 180 degrees. So we're going from this quadrant through this quadrant all the way to this quadrant. And we know that if we're just looking at quadrants, right, we've got 0, we've got 90 degrees, we've got 180 degrees, and we've got 270 degrees there. And if we go all the way around, we go to 360 degrees. So we know we got to go two different quadrants. We got to go through two quadrants in order to get to R double prime. So the answer here is this one, rotation of 180 degrees about the origin, followed by a translation, all right, followed by a translation of X plus 1, Y plus 1. So if I was to just plot that, we already know what the answer is. So I have my triangle there. I'm going to move this triangle. I'll use black to show this one, okay? So this triangle is going to go all the way around, okay? And I'm down 4, 1, 2, 3, 4, and over 2. That's my new point of R prime. But then they say, followed by a translation of X comma Y to X plus 1, Y plus 1. So watch this. X plus 1, Y plus 1. That's my new point. That's my R prime. That's the answer right there. Okay. So the answer is right there. All these others I was able to eliminate. All right. But we got to go through all the different scenarios. We okay with that one? A rotation of 180 degrees followed by a translation. Couldn't be a reflection of the or the translation because R prime, R double prime, and S double prime change positions. All right, so now let's move on to the next one. A trapezoid is shown on the graph below. Which series of transformations will map the trapezoid onto itself? Okay, so now I'm going to look at the different series. So here, I'll use a different color. I'll use green to start. Reflection over the x-axis, then a rotation of 180 degrees. So if we reflect over the x-axis, this is our x-axis. You guys know this, all right? So this is our x-axis. Don't mind my, but that's our x-axis, okay? And now we're just going to reflect this. So the way that this would work is, since we're going across the x-axis, this stays the same and this stays the same. These both stay on the x-axis, all right? And then this point here is negative 4 and 4, okay? So if I'm just reflecting that, it needs to be the same distance and perpendicular to the x-axis. So I'm going to take this down, boom, 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 and I go to -4, okay? And that point is reflected. Now I'm going to do the same thing here. So here I've got the coordinate is 4 and 4. I'm going to, because I'm going across the x-axis, all right, I need a perpendicular line that goes through there, and I go 4 and -4. And we know that these points stay the same. All right, so this is our first. This is a reflection. It's our first transformation. Okay. And then it says rotate 180 degrees. So I'm going to take this figure right here and I'm going to rotate it about the origin. All right, so I'll use a red mark to mark the origin. And all I'm going to do is I'm going to rotate this 180 degrees, or I could go this direction 180 degrees. And look, it maps back onto itself. This would go 2 quadrants over to there. This would go 2 quadrants over to there. So that is my answer right there. That's the first one. Now, let's see. Are there any other options? I want to take a look at something real quick here. Let's see. All right, so that one, we had the correct answer there. But let's take a look at what the other options would look like for us. So if we reflected over the y-axis, okay, what would happen is this point would go to there, this point would go to there. So it's reflecting right on itself, and then we're rotating 180 degrees. So then this figure that I highlight in green would reflect back to here. No, that doesn't work. All right, so I can eliminate that. So it doesn't work. And then we've got reflection over where y equals x, okay? So that is that line there, and we're reflecting over it. No, that's not going to reflect onto itself because that's at a 45-degree angle, and they're saying rotate 90 degrees clockwise. About if it's rotating 90 and we're only doing a reflection of 45, that can't be it. And then a reflection over y equals -2 or y equals 2. So y equals 2, we're reflecting over that. So now we would have a trapezoid that looks like this point would go to here and this point would go to here, and our trapezoid would look like this. And then they say a rotation of 90 degrees counterclockwise. So this would just go to over here, 1 quadrant. That doesn't work either. So the answer there is this first one, where we're doing a reflection over the x-axis and then we're doing 180 degrees about the origin. All right, so that's number 2. Okay, so let's take a look at number 3. What's important here? Bear with me 1 second, I need a sip of water. So that's the first 2.